Hi, this video is about representing free fall in motion graphs. Let's say that you have an extremely powerful arm and you throw a ball upwards at a speed of 40 meters per second. And let's say that there's no air resistance or wind or anything that would affect the flight of the ball other than gravity. So, if that's true, then on Earth, the gravity will cause that ball to accelerate at negative 10 meters per second each second. It's really negative 9.8, but we're going to round it to 10 just for simplicity purposes. So it goes up for 1 second, and 1 second later, it's lost 10 meters per second of its upward velocity. Another second passes, it's at 20. Second number 3, it's at 10. And at 4 seconds, it reaches the peak of its trajectory at 0. Notice how it starts off with a lot of space and it's slowing down, so it's taking up less and less, it's covering less and less distance each second. Now that it's reached its top of its trajectory, it's going to start to accelerate downwards at the same acceleration of negative 10 meters per second each second. So it goes a little bit faster, faster, and then back to where its original height was. It's reached its original velocity, but now it's down in the negative direction. So what would this look like on a velocity time graph? Well, if you look at it, I've plotted the points, these dots right here at each point, we're going to say they're 1 second apart. So this is a time of 0. So at 0 seconds, we started at 40. 1 second was 30, 2 seconds, 20, and you can see the pattern here. It's a pretty consistent line, and that's on purpose because the acceleration is constant. It's always going to be a negative 10 meters per second each second. So it's going to lose that amount for each second. So it ends up looking something like this. And what's significant here at second number 4 is the velocity just for an instant is 0. And so every time a ball reaches the top of its trajectory, it pauses just momentarily, just for an instant, and then starts to turn around and come back the other direction. So what does this look like on an acceleration versus time graph? I'm just going to throw the graph in here, and you can take a look at it. Let me stand up. So an acceleration time graph for this kind of motion is simply a constant negative 10 meters per second per second. The acceleration does not change. It's consistent throughout. It's uniform. Each second that passes, the ball loses negative 10. The ball not loses, but the ball has an acceleration of negative 10 meters per second. So the graph looks like this for acceleration. For position, it's a parabola. In this case, the parabola looks like this, where it starts moving fast and in the positive direction. And then as time goes on, it slows down and eventually stops. And then it starts to speed back up in the negative direction and ends going fast. So it actually just kind of mimics the pattern that's over here, but just plotted on a time graph here. It looks like a parabola. So those are the motion graphs that are associated with an object in free fall. That's all I've got for you in this video. Remember, everything you have is a gift.